All right, 3.3, another angle. The image shows an angle whose rays are tangent to a circle. Mark the approximate points of tangency. So it looks like it's about here, and it looks like it is about here. Yeah, mark the two, or draw the two radii that intersect these points of tangency. Where did I put that? Straight edge. All right. Oh, there it is. Okay. So we're just connecting the dots. Okay. So if this is a radii intersecting with a tangent line, then we know that these two angles have got to be right angles. All right, draw the two radii that intersect these points of tangency. Label the measure of the central angle that is formed W. So they want this to be marked as a W. Great. Okay. What is the value of W plus Z? Explain or show your reasoning. Well, this is actually a pretty quick problem. Because if you can see here, right, what kind of shape have I created with the radii and these two tangent lines? Right, it's a quadrilateral. So what is the sum of all the angles in a quadrilateral? That's going to be 360. So I'm going to write out W plus Z plus 90 plus 90 is equal to 360, right? Because W and Z are two of the angles, and 90 and 90 are another two of the angles. So altogether, it's W plus Z plus 180 equals 360. And then just get W plus Z alone. And that is equal to 180 degrees. All right, so that's interesting. I'm surprised they didn't go a little further with this. So I'm gonna go a little further because that was a little quick. So I'm gonna get rid of that W for a second because it's not super important for this next part. There's actually a much more interesting observation you can make about this diagram. So I'm going to connect the radii to this point where the two tangent lines intersect. All right, and I'm gonna label these two lines as congruent because they are both radii of the same circle. I'm also gonna put an X here because they share this line segment right here by the reflexive property. Then let's label all these line segments. All right, so how can I compare triangle ABD to triangle CBD? All right, what do we think is true about these two triangles? Well, they certainly look congruent. And if you think that they are, you'd be right. Why are these two triangles congruent? Well, let's go through our triangle congruence postulates. SSS? No, don't have all my sides. SAS? No. Well, actually, if we read it, we can see it's just ASS, which we know is no good. However, ASS does work if the triangle is right, because technically what we have here is the hypotenuse of this triangle because it's opposite the right angle, and then we've got one of the legs. So these are congruent by HL. So why is this interesting? Well, always looking for relationships between things in geometry. And by CPCTC, we can say that CD is congruent to AD. So what is this really trying to say? Well, let me just erase all this other sort of, not nonsense, but stuff that's sort of getting in our way here. All right, so this is interesting because if we have two tangent lines that intersect, the distance from the intersection point to the point at which they hit the circle's circumference is always going to be equal. So let's put that into words. If two tangent lines intersect, the distances from the point at which they intersect each other to the point they intersect the circumference must be equal. All right, that's it. Have a great day.